Okay, hello everyone. Welcome to this video here for the equation challenge. So today I'm going to walk through a way to solve some more complicated equations, and hopefully you can learn this new method and apply in this upcoming challenge. All right, let's get started. So today we are going to look at a way to solve some higher degree polynomial equations. First of all, we all know how to solve a linear equation or a quadratic equation, right? Those will be the most basic equations you learn how to solve. However, what if we have some higher degree equations such as like the cubic equations and all the others? Actually, people have try to find some ways to solve this higher degree equations, and the breakthrough was they find this massive formula to solve any cubic equation. But you can see here, the formula is very complicated. And of course, you are not going to memorize this formula to solve the cubic equations. And not to mention, we don't even have a general formula to solve any degree equations. So how would you approach this higher degree equations? Let's learn a way called reducing power. This will be used when you have some higher degree polynomial equations, and it can effectively help you to solve equations like this. For example, when we look at this equation here, we first notice that we have some rational expression in the equation. So we got x squared plus 2 divided by x, and also 6x divided by the x squared plus 2. If we just proceed to cancel out all the denominators, you will end up having a cubic equation. But of course, we are not going to solve just the cubic equation, but instead, let's try to observe some patterns in this equation. So first, we notice that we have the x squared plus 2 in both expressions, right? As you can see here, we have the x squared plus 2 in the numerator, and we have the x squared plus 2 in the other denominator. And what else? If we also look at the other variable x, we can also see that the x appears in both rational expression here, right? So even though we have the 6 in the other one here, but we do see that the two rational expressions have those components in common. Okay, so now we can see that we actually have the same expressions or the same structure in this two rational expressions. And it seems like we can just use one variable to substitute this complicated rational expression. And you can see this will be kind of similar to the method of substitution, but the key idea is that we want to lower the degree of the equation so that we can solve this equation. All right, so now we are going to use this way to solve this equation. Let's take a look. All right, so now let's try to practice and think about how we can solve this equation. As we discussed earlier, seems like we can use one variable to represent the x squared plus 2 divided by x, since we can find this in both rational expressions. So first of all, we are going to use the substitution. So we just let another variable, say the variable y, equals x squared plus 2 divided by x. Like this. So once we make this assumption, we can then substitute into this equation. So therefore, we are going to get the equation becomes y plus a 6 over y. So notice that in the second expression, we do have the reciprocal of the y, right? Because we switched the denominator with the numerator. So it's going to be the reciprocal of the y. So we have a 6 over y. And then this equals, on the right-hand side, we just have the 5, like this. All right, so now this equation is simple enough, and we can certainly solve this equation. So first of all, we have to remove the denominator by multiplying both sides by this y. So we are going to get y squared plus 6 equals 5y. And thus, this will be a y squared minus 5y plus 6 equals 0. And then we can solve this using factorization. So we can do y minus 2 times a y minus 3 equals 0. And we can solve that y equals 2 or 3. But now, since we have already solved the equation in terms of y, this would not be the final answer for this problem because we are still solving this equation in terms of x. Y is only a variable we use to represent this complicated expression. So in the end, we still need to take the values of y to solve the values of x. But you can see here we have two possible values for the y. So we do have to break down into different cases and think about the values of x in each case. So first of all, let's consider the case when y equals 2. So we can first go ahead and consider this case. When y equals 2. If y equals 2, we know that 2 is going to be x squared plus 2 divided by x is equal to 2. And we can also solve this equation by multiplying both sides by the denominator. And we are going to get the x squared minus 2x and plus 2 is equal to 0. So in this case, first of all, we notice that we cannot factor this equation. And second of all, do we have real solutions to this equation? I don't think so, because we can quickly check the discriminant of this quadratic equation. So remember, the formula of the discriminant is going to be the b squared minus 4ac. So actually, because the discriminant is equal to negative 2 squared and minus 4 multiplied by 1 multiplied by 2, and that's going to be a minus 4 less than 0. This equation actually has no real solution. So we know that the equation has no real solution. All right. So here, even though we know the complex numbers, but if we just want to solve the equation, we still don't want to find the complex solutions unless it's specified in the problem. So we are still just saying that it has no real solution. Okay, but we do have another case, and this will be our last hope to solve this equation, and that is y equals 3. Let's also try this other case. So in this case, if we have the y equals 3, when y equals 3, we can still plug in back to solve the value of the x. So we will have the x squared plus 2 divided by x. Is equal to 3. In this case, we can solve the equation to be x squared minus 3x and plus 2 is equal to 0. And in this case, we can quickly solve this equation by just plugging in the value of the, do the factorization. And also you can see that in this case, we will have the x equals 1 or 2. Okay, x equals 1 or 2. And also, since we have the x in the denominator, it's also important to plug in back these two solutions and check whether they work. In this case, if we plug in back to this original equation, we can see both equations work. So we can plug in here just to make sure that the equation is well defined. Okay, so since now we have these two solutions and they all work well with the equation, this will be the final solutions to our equation. So we are going to safely say that the solutions will be 1 and 2. And that's it. So now you can see that this will be the formal way to use this reducing powers and solve this equation. Okay, so see you next time, and hopefully you can get a good result in the equation challenge. Bye, guys.